Hello, students, and welcome to your math lesson today. We'll start with our do now, and we're going to have a prompt about a life plan quote, something that someone said, and we're going to give our impressions and reactions of that. Our objective today will be to continue our exploration of exponents, and we're also going to add to it today an understanding of negative exponents. Our essential questions ask, what is the negative exponent rule? We'll find that out. And how can I write an expression that contains negative exponents so that it contains only positive exponents? Because mathematicians, we don't like to leave those negative exponents in there. We like to find a way to write our exponents as positive. So after we watch the video, or as we watch the video, we'll complete 2 assigned pages today. The first page is a chart very much like the one you did yesterday, but with slightly more difficult problems. Let's pay special attention to the negative exponent rule. And remember, show all of your work, not just the answers. Our exit ticket today asks, when I have a negative exponent, I should, and we're asked to fill in the blank. And we're also going to give an example of that. And make sure you show your work to me either on the video or during class on the meeting, or you can send a photo of your work to my email address, which is right here. And we don't have homework unless we haven't finished the lesson. And I think you'll finish today's lesson. It is a little longer than some of them, but I think you'll get done. So let's remember, you guys, some of you have been great about putting your camera on, just, for our do now discussion and to kind of be conversational with each other at the beginning of class. And I may call on you at any time during class. So please make sure that you are there and available, unless I've dismissed you early. And we talked about showing me your work. Now, you need to know that starting next Wednesday, I've mentioned it before, but now I've got it in our opening credits, so to speak, so that you remember. It's a full day, okay? So it's not just, dial in and take a survey or a quick quiz. We've got a full day of classes. So you'll use your calendar like you have been doing on Monday, Tuesday, or Thursday, or Friday, and depending on what cohort you're in, and you're going to dial into your meetings, your classes all day, all 7 periods next Wednesday. So, you might want to pack a lunch even while you are at home, because you only have 30 minutes from 12:15 to 12:45. So maybe, pack your lunch in the morning or the night before so you can have that quick sandwich or whatever it is you like to eat. Leftovers are always good, aren't they? You need to have that ready for your lunch. And we're still celebrating the new year. And we have an entrepreneur, his name is Jim Rohn, and he had this quote. And the quote is enclosed in quotations. And it says, if you don't design your own life plan, chances are you'll fall into someone else's plan. And guess what they have planned for you? Not much. So what did he mean by that? What do we think he meant? And what is it to fall into someone else's life plan? I guess one way to look at it is, if you aren't anxiously or actively pursuing something that's your own dream and your own goal, somebody might ask you to come work with them on something. You will be helping them fulfill their goal, but it might not be what you really want to do in life. So take a few minutes and think about that quote and write your reaction in teams. We'll come back to our exit ticket later. So let's get started with this big lesson on exponents. And I hope you all have your notes ready. So some of this is review, okay? So let's, but review is always a good thing. So in the case of repeated multiplication with the same number, okay, I've said this to you over and over, an exponent is repeated multiplication. Now, we can write the expression using exponents. For example, 4 times 4 times 4 would be 4 to the third. And the large number, is called the base, and the smaller number, which we're calling n here, is the exponent. And we talked about expanded notation, exponential expression, or we call it, we can call this the value, we've called it also standard notation. So why don't you go ahead and write that in your notes? So if we have an expanded notation of 11 times 11, that would be 11 to the second power, and 11 times 11 is 121. If you don't know your times tables, you can always take out a calculator and get a little help with that. So let's count the number of twos. 1, 2, 3, 4, 5, 6, 7. That would be 2 to the seventh. And 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128. Now, be careful with the negative numbers. We have 4 negative 5s. This is not 4 times negative 5. This is negative 5 times negative 5 times negative 5 times negative 5, or negative 5 to the fourth power. And notice how I put that in parentheses. Well, when we evaluate this, a negative times a negative is a positive. So that would be positive 25, and 25 times negative 5 would be negative 125, and negative 125 times negative 5 would be a positive, because then we're back to positive again, where a negative times a negative is a positive. So that would be positive 625. 1/4 times 1/4 times 1/4 is 1/4 to the third power. I think the easiest way to do this, you could say, you could multiply the first two numbers and then take the answer and multiply it by the third. Or you could say 1 times 1 times 1 is 1. 4 times 4 times 4 is 64, and those are positive numbers. So that would be 1/64. Now we're combining expressions. We've got 7 times 7 times, be careful here, 4 times 4 times 4, which would be 7 to the second power times 4 to the third power. Well, 7 to the second power is 49. 4 to the third power is 64. 49 times 64 is, I'll write that up there, 9 times 64, and that would be 3,136. Now, number 6, we have the numbers, the values are mixed up. We've got 8 times 8 times 8 times 8. Now, remember, addition and multiplication are commutative, so order does not matter. So we can do these, we can rearrange this order to be 8 times 8 times 8 times 8, and then times -2 times -2 times -2. And that would be 8 to the fourth times -2 to the third power. Please make sure with these negatives that you use parentheses. And then 8 to the fourth on its own, 8 to the fourth power is 4,096. And -2 to the third power is -8. And -8 times 4,096 equals negative, because negative times a positive is a negative, negative 32,768. Now, the same thing here. We can reorder this problem so that we have 2/3 to the second power times 9 to the second power, because it's repeated 2 times, the 2/3 and the 9. So 2/3 to the second power equals 0.44, and You can use a calculator to get that. And 9 times 9, or 9 to the second power, is 81. Well, 0.44 times 81 equals 36. Now, how many a's do we have here with this variable? The exponents work with variables as well. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a being multiplied by itself 9 times, and that's a to the 9th power. But there is no standard notation for this because it's a variable. And let's look at xy. So we have to think of xy as one term. It's repeated 1, 2, 3, 4, 5 times, and that would be x, y, keep the parentheses, to the 5th power. And again, there's no standard notation for a variable. Here we have to carefully count our r's, and I'm going to go in alphabetical order. I have R, S, and T. I've got 1, 2 r's, and everything is being multiplied. So that's r to the second times 1, 2, 3, 4, 5 s's, so that's times s to the 5th times 1, 2, 3 t's, which is t to the 3rd. And again, no standard notation for that. Now we've got some k's and some 9s. I'm going to do the 9s first, and then I'll do the k's. So I have 1, 2, 3 9s. That would be 9 to the 3rd times k to the 1, 2, 3, 4, 5, 6, k to the 6th. So that would be 9 to the 3rd, k to the 6th. 9 times 9 times 9 is 729, and k to the 6th we cannot standardize. So that would be 729 k to the 6th. And similarly, with number 12, we have -7 2 times, it's multiplied by itself. Use parentheses, -7 squared times, how many m's do we have? M to the 1st, 2nd, 3rd. M to the 3rd times n to the 2nd. Now, -7 times -7 is 49, and then we just write our m to the 3rd, n to the 2nd. And now with our p minus 2, it's written as a quantity, so we will just copy it just like that, p minus 2. It's repeated 3 times, so that's p minus 2 to the 3rd. And our last one, we have a plus b times 6 times 6 times a plus b times 6. So let's start with the 6's, 3 of them, 6 to the 3rd, and they're multiplied. It's not addition, so it's an exponent. 6 to the 3rd times a plus b, but it's repeated, so it's raised to the 2nd power. Well, 6 to the 3rd is 6 times 6 times 6, which is 216, and then we just rewrite the a plus b to the 2nd power. So let's move on to the next page. Now, here we have the zero exponent rule. The zero exponent rule tells us that any number except 0 raised to the 0 power is defined as 1. So 1 to the 0 power is 1. 2 to the 0 power is 1. 3 to the 0 power is 1. 4 to the 0 power is 1, and x to the 0 power is 1 as long as x does not equal 0. Now that's the zero exponent rule. Now we have the negative exponent rule, and the negative exponent rule says that any number raised to a negative exponent equals the number as a denominator with the same exponent in a positive fashion if it's written under 1. So x to the -1 equals 1 over x to a positive n. X to the negative n equals 1 over x to the positive n. So we can get rid of this negative exponent by putting it as a denominator under 1. This only works if x does not equal 0. So let's do some practice with these negative exponents. And also with, let's see, maybe we have some 0 exponents too. So 5 to the negative 2 power is the same as 5 to the 5 squared, or 5 to the second power, written as a denominator under 1, and that would equal 1 over 5 times 5, which is 25. Now 8 to the negative second power can be written as 1 over 8 to the second, which would be 1 over 8 times 8, which would be 1 over 64. Now, number 17, 9 to the negative 1 power would equal 1 over 9. When we can say 1 over 9 to the first power, but we don't write the first power, so we just write 1 over 9. And next we have 4 to the negative 4th power, which we will write as 1 over 4 to the 4th power, which is 1 over 4 times 4 times 4 times 4, which equals 1 over 256. Now, number 19, 10 to the negative 3rd power is 1 over 10 to the 3rd power, which would equal 1 over 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So that would equal 1 over 1,000. Remember, if this is too fast for you, you can slow down the video or you can rewatch it. All those options available to you. Try to do the next few on your own. Let's see how you do. Pause the video and try them. Okay, let's see how you did. So this should be 1 as the numerator, 2 to the 7th as the denominator. So that would be 1 over 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 2's, which would equal 1 over 128. Okay, number 21, we're multiplying now. We have an operation. So we'll start with 1 over 4 to the 3rd times 1 over 7 to the 1st power, which would equal, the 4 to the 3rd is 1 over 64 times 1 over 7, which would equal 1 times 1 is 1, 64 times 7 is 448. And number 22, we have 5 to the negative 4th power, so that would be 1 over 5 to the 4th times 3 to the negative 2nd power, which would be 1 over 3 to the 2nd power, and 5 to the 4th power equals 625 times 1 over 3 to the 2nd power is 3 times 3, so that's 9. And when we multiply across, our numerator is 1, and our denominator is 5,625. Number 23. 3 to the 4th is 3 to the 4th. We don't need to put it under 1. It's a positive exponent. So we'll multiply that times 9 to the negative 2nd, which would be 1 over 9 to the 2nd. Now we can write 3 to the 4th as 81. because it's 3 times 3 times 3 times 3. So 81, we can put any whole number over 1 without changing it, times 1 over 9 times 9 is 81. If we multiply across, we have 81 over 81, which equals 1. Number 24. So we have 8 to the negative third. That would be 1 over 8 to the third times 10 to the second times 4 to the 0 power. Anything raised to a 0 power is 1. So let's rewrite this. 1 over 8 to the third is 512 times 10 times 10 is 100. And then anything times 1 will stay the same. So when I multiply across, I have 100 over 512, which simplifies. We can divide both those numbers by 4, so it will simplify to 25 over 128. So 25, number 25, x to the negative ninth. Okay, same rule, even though it's a variable, we put it under 1 and we keep the same exponent. We just remove the negative sign. A to the negative fourth, put it under 1, remove the negative sign. Okay, we're being challenged a little bit with number 27. We have r to the negative 6, so that would be 1 over r to the 6 times anything to the 0 power equals 1 times t to the 11th. And the way we write this, t to the 11th can be thought of as t to the 11th over 1. So if we multiplied everything across, we would have in the numerator t to the 11th over a denominator of r to the 6th. Let me rewrite that so it's a little clearer to see. So that's r to the 6th power in the denominator. And then finally, 3 to the negative third is 1 over 3 to the third times 1 over m to the fourth times n to the fifth. And when we multiply across, we would have in the numerator 1 times n to the fifth, because we can think of that as a denominator of 1. So our numerator would be n to the fifth, and our denominator would be 3 to the third, which is 3 times 3 times 3, which is 27, times m to the fourth. And times 1 doesn't change anything. Remember that we multiply straight across when we do these fractions. And the 3 times 3 times 3 is 27. And then we're multiplying times n to the fourth, which we cannot simplify any further. So we are done. So the summary, anything with a 0 exponent except 0 itself equals 1. And then we can omit or get rid of a negative exponent by putting it under a numerator. And you can go in the other direction as well. If you have a negative exponent, you can make it positive by putting it in the denominator. If you have a whole number exponent in the denominator and you needed a negative exponent for some reason, you could just pull it out from under the denominator to do that. So let's go back to our exit ticket. When I have a negative exponent, I should make it a denominator and remove the exponent. Remove the negative sign. So for example, if I have 6 to the negative ninth, then I would write it as 1 over 6 to the ninth. If I have x to the negative 13th, I would write it as 1 over x to the 13th. Don't forget to show your work to me. Keep working hard. Go review this video again if you think it was unclear, and make sure to ask for help. You guys have been working really hard. I loved our conversations. I love seeing your faces in our Teams meeting, and I want you to just keep working hard and practicing, because you know what happens if you practice. You'll be great.